Uh, this example wants us to find cosine of 270 degrees. Now, the difference between this type of problem is that, yeah, the theta is known. And remember how I'm telling you two types of problems, either theta is known or theta is not known. In either way, you're going to sketch it, but if theta is known, start with sketching that. What do you notice about theta here? Yeah, it's going to land exactly on this axis right here on the negative y-axis. Let me do a different color. Now, the problem here is that usually when theta was known, we draw the right triangle associated with this by going from the terminal side to the horizontal axis. Can you draw a right triangle here? No. So that's why when it lands on the axis, the special right triangles, it's not going to work. Okay. So what do you do from here? All right. There's a couple of ways of doing this, and next couple of sections from now, we're actually going to look at a different way using the graph of how to evaluate cosine of 270, which is actually going to probably be a lot easier than this. But I still want you to know how to do this with the sketch. Now, last time we looked at the formulas, which are actually still here on the board. But in case you forgot them, and that's why I'm telling you, I wouldn't suggest you try to memorize all of these, like cosine of theta is x over r, sine of theta is y over r. Let's say you forgot them. Just simply make a point x comma y, preferably on the first quadrant to make things easier, and just create your sketch yourself. If this is x comma y, that means this here is x because I go first the x units, and that means that this is y, and I know that this is labeled as the r. Now, based on SOHCAHTOA, let's say I forgot my formula. What is cosine of theta equal to? Adjacent over hypotenuse, and on my sketch, it's what? X over r. So this is what I'm going to use to help me evaluate this on my sketch. Now, the only thing is that you notice that the r is a terminal side. So what we're going to do is choose any value for r. They prefer to use r equals 1 because that's the easiest one to work with, but technically you could use any of them. Okay? And remember that the r is the length of the terminal side, according to the pictures. Terminal side. Let's make things easy. Let's choose r equals 1. So that means that from here to here, the distance is 1 unit. Now, if I go to my sketch, if that terminal side measures 1 unit in length, what are the coordinates here? If you plot 0, 1, where is it going to be? One zero zero one. But isn't 0, 1 up here? 0, negative 1. Okay, so be careful here because the length of the terminal side is 1 unit, but that's pointing downward, and the y value, it's like if I ask you to plot this point right here, then you would say the x value is 0, the y value, since this is 1 unit, it goes down to negative 1. And now, based on this, this is x, this is y, and I already found out that cosine of theta was x over r. So now evaluate cosine of 270 with the sketch. The x value is what? 0. What is the r that I chose? 1. So what is 0 divided by 1? 0. Okay. Like I said, it might seem like a lot of work, but we want to get used to the fact that most of these we won't have a calculator, and sometimes you will forget those formulas. So might want to break it up into knowing where theta is or where theta is not. Had they asked for sine of theta, even though they didn't ask it, or sine of 270 degrees, what is that? Opposite over hypotenuse, which is y over r, which is negative 1 over, what's the r? 1. So it's equal to negative 1. Okay. And you could confirm this on your calculator if you actually go ahead and put cosine of 270 degrees, you get 0. If you type in sine of 270 degrees, you also get, or you get the negative 1. But like I said, the idea is that you want to start doing these without a calculator. And like I said, later on in the sections, we're going to look at a different approach using the graphs on how to evaluate these that land on the axis, the 90, the 180, the 270, or the 360. Any questions?